One of our most prominent polyols applications, foam, demonstrates several clear advantages compared to commonly used materials. Let's walk you through the tests we've performed to prove this statement. The test for tensile strength shows how resistant the foam is to breaking under tension. The addition of Kuraray's polyols strengthens foam to extend its breaking point. While most foam materials break at 298 psi, with the addition of our polyols, the foam will stretch to 428 psi before breaking. This creates a tensile strength that is 1.4 times stronger than that of other common materials. The test for tensile elongation shows the strength of the foam as it's stretched under tension. The addition of Kuraray's polyols increases the strength and therefore the ratio of the length from the resting state to the breaking point. The increased flexibility allows the foam to elongate to 373% of its original length versus how common materials can only stretch to 268% of the foam's initial length before breakage occurs. The test for tear strength indicates how well the foam can withstand tearing when it's stretched. The addition of Kuraray's polyols strengthens the foam to withstand tearing. While most foam tears at 136 Newton-centimeters, when you add Kuraray's polyols, the foam doesn't tear until 185 Newton-centimeters because it's able to withstand the power of force better. The abrasion resistance test shows the ability of the foam to resist surface wear caused by rubbing contact. Foam can withstand abrasion at a markedly higher rate when we add Kuraray's polyols. When using Kuraray's polyols, there is no loss to the foam observed during the abrasion resistance test. Other foam loses approximately 370 milligrams of its material during the abrasion process. The compression set test measures the ability of the foam to return to its original thickness after it's compacted. The addition of Kuraray's polyols helps the foam to maintain its original shape. Once compressed, other materials do not bounce back at the same degree as foam made with Kuraray's polyols. The foams using our products not only hold their shape longer, but also resist permanent deformation better. The shock absorption test shows the damping ability of foam. The addition of Kuraray's polyols helps the foam to absorb the external force. When you drop the ball on standard foam material, it bounces back to 46% of the original height, which indicates that it does not absorb the shock of the ball well. When you drop the ball on foam that uses Kuraray's polyols, it bounces back to only 17% of the original height. From this test, we can conclude that foam using Kuraray's polyols has excellent shock absorption. Hysteresis testing is a form of stretch testing. It shows the same trend as elongation set. Current research indicates that hysteresis values may provide a good indication of overall foam durability after being flexed. Lower hysteresis values are desirable. Do you notice the difference in cycle 1 and cycle 10? The force difference between cycle 1 and cycle 10 indicates that the foam quality over time is higher quality when you use Kuraray's polyols. Why is this important? There are several clear advantages when using Kuraray's polyols instead of traditional materials in foam applications. What's the next project you're dreaming of? And how can we help?